Lesson 5.6, the law of cosines. In this lesson, we're going to go through another equation that we can use to solve any triangle, not just right triangles. So the law of cosines, if we have a triangle ABC, there's three basic equations that we can set up. If we're trying to find side length C, we can set up c squared equal to a squared plus b squared minus 2 times a times b times the cosine of C. So if we have a side length isolated by itself, on the other side of the equation, we're going to use the other two side lengths. The angle that we're going to use, take the cosine of, is going to correspond to the side length we're trying to find. Then we also have similar equations for side length B and side length A. If we're trying to solve for an angle using the law of cosines, we can take this first equation and isolate to get the cosine of C by itself. So using inverse order of operations, first we would subtract a squared and b squared to the other side, then divide by negative 2ab. So the equation down below that you see we can get for the cosine of C is c squared minus a squared minus b squared, all divided by negative 2ab. At this point, the last thing you would do to find angle C is take the inverse cosine of whatever this value simplifies down to be. Example 1, we're going to solve triangle ABC. So the information we have is that length B is 5, length A is 11. We don't know what side length C is. We know what angle C is, that's 20 degrees, but we don't know angle A or angle B. So the first thing we're going to do is use the law of cosines to find side length C. So plugging in the known information, we get c squared equal to 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. At this point, we just have to use a calculator to simplify the right portion of our equation and then take the square root of that result. So simplifying the right side, we get c squared equal to approximately 42.634. And then if we take the square root of both sides of the equation, we get C is approximately 6.53. Now that we know what all three side lengths are, we need to solve for the two missing angles. So it doesn't matter if we choose to solve for A or B. Once we have the other one, we just have to take 180 minus those other two angles to find the missing one. So suppose we want to find the measure of angle B first. We can use the law of cosines to get angle B isolated by itself. So we get the cosine of B equal to 5 squared minus 11 squared minus 6.53 squared, all divided by negative 2 times 11 times 6.53. So first simplify the right side of the equation, and then we're going to take the inverse cosine of that result. So the cosine of B is approximately 0.96506. Then to get B isolated by itself, we have to take the inverse cosine of each side of the equation. And if we do that, we get approximately 15.2 degrees for the measure of angle B. Now the last thing we need to do is find the measure of angle A. And so the measure of angle A will be equal to 180 minus 20 minus 15.2. So the measure of angle A is approximately 144.8 degrees. So we use the law of cosines to first find the missing side length, then we used it to find one of our missing angles. Once we had that angle, we could use the idea of the triangle sum theorem, 180 minus the two angles to find the remaining angle. Example 2, we're going to solve triangle ABC again using the law of cosines. In this particular example, we know all three side lengths. We don't know any of the missing angles. So we have to use the law of cosines twice to find two of the angles. Once we have those two angles, just subtract them from 180 to find the remaining one. So the first equation we can set up to solve for angle C is the cosine of C equal to 5 squared minus 7 squared minus 9 squared, all divided by negative 2 times 7 times 9. Remember from the formula, if we're looking for angle C, the first side length we're going to have in our equation is side length C. So whatever angle we have, that's going to include the first side length we have in our equation. And then if you go through the same process we did last time, simplify the right side of the equation, and then take the inverse cosine of that result. And if you do that, you get C is approximately 33.56 degrees. Now we can use a similar process to find the measure of angle B. So the equation we can set up is the cosine of B is equal to 7 squared minus 5 squared minus 9 squared, all divided by negative 2 times 5 times 9. Remember that if I'm looking for angle B, the first side length I have is going to be side length B, which is 7. Now if we plug this in, simplify the right side, and take the inverse cosine of that result, you get B is approximately 50.7 degrees. So now that we know what the measure of angle C is and the measure of angle B, if we're looking for the measure of angle A, that is going to be approximately 180 minus 50.7 minus 33.56. So it'll be approximately 95.74 degrees. To end this lesson, we're going to go through a couple new formulas that we can use to find the area of a triangle. The first one we're going to discuss is if we have two side lengths and the included angle between those side lengths. All three of these formulas or these equations are following the same general pattern. So if we had a triangle where we knew side lengths A and B and we knew the angle C between them, we could use this formula. So the area is equal to 1/2 times A times B times the sine of that angle C. So an example using that previous formula, if we have triangle ABC, we know side length A is 7 units, side length B is 6 units, and the angle between them, angle C, is 60 degrees. So the formula we can use is the area is equal to 1/2 times our two side lengths, so 1/2 times 6 times 7, and then we're going to multiply that by the sine of 60 degrees. So now you would just plug this in on your calculators to get that approximation. After plugging that in, you get the area to be approximately 15.16 units squared. The second formula we're going to discuss involving the area of a triangle is Heron's formula, which is the area is equal to the square root of S times the quantity of S minus A times the quantity of S minus B times the quantity of S minus C. S is called the semi-perimeter, so we're adding up all three side lengths of the triangle and dividing it by 2. Okay, A, B, and C being the sides of our triangle. Now in the last example, we're going to use Heron's formula to find the area of a triangle with side lengths of 13, 15, and 18. So the first thing we need to do is find the semi-perimeter, which we find by adding up all three side lengths and dividing by 2. Thus, if we take 13 plus 15 plus 18 and divide that by 2, we get the semi-perimeter to be 23 units. Now we just have to take Heron's formula, plug in the values we know for S, A, B, and C. Using that formula, we get the area equal to the square root of 23 times the quantity of 23 minus 18 times 23 minus 15 times 23 minus 13. You can plug all this into your calculator, or you can simplify this before doing that. So you could take the square root of 23 times 5 times 8 times 10. If you plug that in, you get the area to be approximately 95.92 units squared. So that would be the area of a triangle that had side lengths of 13, 15, and 18. That's utilizing Heron's formula. You're finding the semi-perimeter, and then using that and the three sides of the triangle, plugging that into the formula and just simplifying.